Our coastlines, they're some of the most vital, most vibrant ecosystems on the entire planet. But they're also incredibly fragile. So how are we supposed to protect them if we can't even see the full picture? Well, what if we could build a digital brain for our oceans? That is the incredible, ambitious goal of a project called Blue Data.
Just look at this image. It shows the challenge perfectly, doesn't it? It's this complex, interconnected world of water and land and life. Places like the Gulf of Guinea are just bursting with biodiversity, but at the same time, they are under immense pressure from climate change and, of course, human activity. So, how do you manage something this intricate effectively?
And that brings us to a really fundamental principle. You can only manage what you can measure with precision. And when it comes to our coastlines, our inability to measure accurately, well, that's the heart of the crisis.
This problem has a name, and it's what we can call decisional blindness. It's that huge gap between the desperate need to act and the ability to see clearly enough to make the right call.
So here's the reality for the people on the ground. The managers who are in charge of protecting these areas, they are often working with bits and pieces of scattered information. I mean, imagine your fisheries data is in one office, water quality tests are in another, and satellite imagery is with some third-party vendor. It's up to a manager to try and piece that whole puzzle together. It's like trying to navigate a ship in a storm with a torn map. You're forced to be reactive, not proactive.
But what if we could change all of that? What if we could give coastal managers a clear, forward-looking view? This is exactly where Blue Data comes in.
Okay, so Blue Data isn't just another data portal or some fancy map. It's better to think of it as an intelligent operating system for the coast. Its mission is actually pretty simple, but incredibly powerful. Bring all the relevant data together, use AI to predict what might happen next, and then provide clear, actionable recommendations.
So how does it work?
Well, the tech behind Blue Data is built on three main pillars. First up, big data. It pulls in everything: satellite images, field measurements, economic data, you name it, and fuses it into one unified database. Second, AI analysis. It uses deep learning to model what might happen in the future. And third, adaptive AI. This is the part that actually recommends solutions and sends out early warnings based on those predictions. It's a complete cycle, from data all the way to decision.
So how does Blue Data make sense of all this information? It organizes everything into 4 key pillars of insight, which we'll get to in just a moment. But first, let's see how all this power actually gets delivered to the user.
And this is the end result. All that complex data gets transformed into this, an intuitive, interactive geoportal. Now, managers can see different layers of information, they can track changes over time, and they can explore the health of their marine protected area from every possible angle.
This right here is the framework that makes the system so powerful. See, it doesn't just look at fish and coral. That's the biophysical part. It also analyzes socioeconomic factors, like pressures from local communities. It measures management effectiveness to see if conservation efforts are actually, working. And, critically, it looks at governance. Are local stakeholders involved? Are the decisions being made seen as legitimate? It gives you a complete 360-degree view. And this part is absolutely crucial. The system is built with data security and sovereignty at its very core. It uses what's called role-based access, which just means different users get different levels of permission. This makes sure that sensitive info is protected and, most importantly, that the local stakeholders and nations own and control their own data. That's how you build trust and empower local governance.
This holistic approach really allows for a fundamental shift in how we think about conservation. We're moving from this defensive, reactive posture to an offensive, predictive one.
Let's just pause on this for a second, because the comparison is so important. The old way, well, it's about putting out fires. A crisis happens, you scramble to respond. The Blue Data way is about fire prevention. The system's integrated intelligence lets managers see the sparks before they become ablaze, which lets them act proactively with solutions that are targeted and way more efficient.
And the AI does this in 3 distinct phases. First, it detects anomalies in the data, things like a sudden drop in water quality or unusual fishing activity. Second, it predicts where these trends are heading. And finally, based on those predictions, it advises on the best possible actions to take. And it's always learning, always getting smarter over time.
And here's where it becomes incredibly practical. This isn't just some theoretical analysis. Blue Data actually works as an early warning system. When the AI detects a significant threat, it automatically sends alerts to managers through email, text messages, and right on the main dashboard. This allows for immediate, informed action right when it matters most. So this technology sounds amazing in theory, but where is it actually being put to the test? And what's the long-term vision here?
Right, so this isn't just a concept, it's already in action. The pilot phase is happening right now in the Manyanye na Elombo Campo Marine Park in Cameroon. This is the real-world proof of concept, showing exactly how this digital brain can empower conservation on the ground.
And the ambition here is truly inspiring. While the challenge of protecting our oceans is global, this is a made-in-Africa solution. It's designed from the ground up to be modular and scalable, with a vision to expand across the Gulf of Guinea and hopefully beyond, offering a powerful new tool to the whole world.
So it leaves you with a pretty powerful thought, right? We've spent centuries trying to understand the ocean from the outside. But what if the real breakthrough comes from giving it a way to speak to us directly through data? What if the key isn't just about observing the ocean, but finally learning how to listen to its digital voice?